Before we can talk about how to electrically test a motor or generator, we need to know something about the construction of a stator. A stator is made out of laminations like this one. This is actually the lamination of a rotor, but the stator is identical in that it is a stack up of many laminations of electrical steel. Each lamination has a number of slots. So if I draw one slot of a stator lamination, like so, you can see here that that's been punched into this lamination. As we assemble many laminations together, we end up with a long stator core, which I can draw like this. Into this slot, we're going to install this stator coil. This is a form-wound stator coil, which will be about 99% of the machines you work on. Form-wound coils are used predominantly in machines over 1,000 volts. So 2400, 4160, 13,000 volt coils are going to be, by and large, form-wound coils. And what that means is the magnet wire, which is used to make the coil, will have a rectangular section. So here I've got 4 and 4 wires that have been turned around to form this coil and then insulated. So if we zoom in as shown here, we can see that we've got our magnet wire. I'll just draw 2. Around each rectangle, there will be a coating of varnish, which is applied at the copper provider. Around that varnish, we apply some tape, and then after we bundle the coils together, another layer of tape is applied, and you can see that here. It looks sort of like a tennis racket or a hockey stick. This provides the electrical insulation because our laminations are ground, and in this coil, we're going to have our voltage, maybe 4,160 volts, or even 13,800 volts for a larger machine. And we don't want this voltage to show a current leaking to ground. That would damage the machine. Now I've drawn the outer coil of this slot within the stator assembly. There would be another coil here made up of the same quantity of sections of magnet wire, also insulated, and in between them a center strip, because these are not the same coils. This coil would connect to a different position located some slots away. But all of these magnet wire sections will be at the operating voltage, and we need to make sure that they're all well insulated from ground. This is the purpose of electrical testing. For stator electrical testing, there are 3 basic tests which provide similar kinds of results about the quality of the insulation between the coils and the ground, which is the laminations that make up the stator core. The first test is called the insulation resistance test, or IR for short. You'll hear about an IR test, often called a Megger test, a lot. Basically, what we're going to do is apply a test voltage to the stator coils with obviously 1 lead of your tester on the coils and 1 lead on ground, which would be the frame of the unit. We're going to apply a voltage and we're going to measure the resistance, which is why the test is called insulation resistance. So refer to your table to determine what voltage to apply. It will be based on the condition of the machine and on the rating of the motor or generator. The second test is called a polarity index, or PI test. This is the same as the insulation resistance test, but instead of performing the test for 1 minute, we'll continue applying the voltage for 10 minutes. The reason we do that is as we apply voltage to this system, we'll actually be adding little electrons inside the insulation system, which will fill it up. So the insulation resistance should increase with time. So if I make a plot of time and here the resistance, we should see the resistance continuing to increase. And if I plot 1 minute and 10 minutes, and I divide the two, if I divide the resistance at 10 minutes by the resistance at 1 minute, the value should be greater than 2. So if the resistance is increasing with time and the resistance at 10 minutes divided by the resistance at 1 minute is greater than 2, we can say that we have a successful polarity index test for that machine. The final test is called a step voltage test. In this case, we'll actually bring the voltage up using the different increments on our tester, perhaps 500, 1,000, 2,500, and 5,000 volts, and we'll hold each point for 1 minute. What we want to prove there is that the resistance goes up basically linearly with the voltage value, and that would give us an indication that the insulation resistance is the same strength for all of these voltage values. In no case do we want to exceed the rating of the machine, because that would become a destructive test. So if you have a motor or generator that operates at 4160 volts, we don't want to apply 10,000 volts to that machine. 5,000 volts DC would be acceptable if it's clean and dry, but we don't want to be applying 2 times the rating, as this would have the propensity to damage the stator windings.